Oh, hi there. Let's talk about inertial reference frames. We've been talking about a lot of problems where there's something moving along. Imagine I had a problem where there's a car, and that car was driving along. That's a pretty nice car, at a velocity of 10 meters per second. It's a really easy place to start, but there's a problem with it because it's moving 10 meters per second from my perspective. But what about the guy inside the car that's driving it? And you might say, well, he sees 10 meters per second too. He looks at his speedometer and it says that's how fast he's going. But not really. I mean, think about it. As he's sitting in that car, and you say, look down at the car, where's the car going? Well, nowhere. So relative to him, the car's not moving at all. It's kind of like if you look down right now at your feet. If you're standing on Earth, Earth isn't moving. But we know that Earth is moving, it's spinning in a circle, and that rotating sphere is also going around the sun, and the sun is also going around the center of our solar system. So there's actually a lot of movement, but relative to us, it doesn't look like we're moving. So this concept of relativity is a really important concept. That's why Albert Einstein spent so much of his time talking about it. But we're going to look at it from one particular view. We just want to talk about these things called reference frames or inertial reference frames. And all that really means is which viewpoint you're looking at the situation. So I already talked about this guy in the car, and imagine he's driving down the road, all right? And what if there's another person standing by the side of the road? Well, if this person had a little speedometer and was shining it at the car, he would read 10 meters per second on the speedometer. But a person in the backseat of the car would read, if he shined at the car, 0 meters per second. They are in different reference frames. They're framing the thing they're viewing from different perspectives. Just like if I had another car over here driving the opposite way. Suppose this car is driving 12 meters per second this way. Now, observer A is going to say that car is driving 12 meters per second to the left. Observer B, the person in car number 2, is going to say, I'm not moving at all. But he's going to look at this car and say, that car is coming to me, towards me, at 22 meters per second. You know, if I were to draw this picture again from the reference frame of person B, they are staying perfectly still in a car that's not moving. And you have this person on the side of the road that's coming at them at 12 meters per second. And you have this other car coming towards them at 22 meters per second. This is what person B sees. In their reference frame, that's what's happening. This is drawn in the reference frame of person A. Now, we're not really going to have too much trouble in terms of picking reference frames. Generally, we're going to think about a person standing on the side of the road watching everything unfold. But it is important to recognize that all motion is relative. If I'm coming at you at 60 miles per hour, that's one thing. But if you're sitting in the car right next to me, it's like we're not moving. So for some of your problems in your homework sheet, you're going to talk about inertial reference frames. Hopefully this helps kind of frame it a little bit. And that's it for now. Bye-bye.